All right, guys, today we're going to be starting on one of my favorite things we learn all year in pre-cal, and that is trig on the unit circle. As you can see, it says day one notes. We're going to be breaking this down into 3 days worth of content. So we're just getting the basics today. We're going to start off up at the top with these two little goober guys that I put on here. I put them on here because we're going to put in those blank areas some very important information. And that important information that we're going to put are our special right triangles. Because in order to evaluate trig on the unit circle, we've got to know our special right triangle lengths. So the unit circle, as you remember last week, is that circle with a center on the origin, has a radius of 1, and we learned the key angles in degrees and radians that go around that unit circle. So some angles that we talked about in the week prior were 45-degree angles and special right triangles that had 45, 45, 90 angle measurements. So let's draw that one first. 45, 45, and 90. You'll remember that when we talked about it, we labeled the leg lengths x, x, and x root 2. Now, on the unit circle, x is always going to equal 1. So our legs are going to be 1 and 1. And if x is equal to 1, the hypotenuse is going to be 1 root 2, or we can just call it square root of 2. I don't know why it's not letting me erase, but that would be 1 root 2. So we call that square root of 2. So in that little box underneath there, I want you to put 45, 45, 90, and the leg lengths that are going to go with that. So in a 45, 45, 90 triangle, you're going to have a leg length of 1, 1, and a hypotenuse of square root of 2. Similarly, we talked about our 30, 60, 90 triangles. You'll draw one of those by that egg-shaped head. 60, 30, 90. We labeled the side that was across from the 30-degree x, across from the 60-degree x root 3, and across from the 90, 2x. But just like in the triangle before, x is going to be equal to 1 on the unit circle. So our side lengths are going to be 1 across from the 30-degree angle, square root of 3 across from the 60, and 2 is our hypotenuse. So to sum it up, let's put it in that table right beneath there. In a 30, 60, 90 triangle, the side across from the 30-degree angle is 1, the side across from 60 is square root of 3, and the side across from 90 is always 2. Now, I want you to take your highlighter out and highlight these lovely tables because those side lengths are going to show up over and over and over and over again. So now I want you to get some steps down before we get going. How are we actually going to evaluate sine, cosine, and tangent of angles on the unit circle? Well, first of all, you're always going to be given an angle. Your first job is to determine which quadrant theta lands in. Determine which quadrant theta lands. So for example, if I asked you to find all 6 trig functions of 5 pi over 4, you would have to figure out what quadrant does 5 pi over 4 land in. Your next step is to determine the reference angle. Remember, with unit circle angles, it is always going to be 30, 60, or 45 degrees. Now, remember that 30 degrees reference angle is always going to be associated with anything in radians that ends in pi over 6. 60 degrees is always going to be with something that ends in pi over 3 in radians. And a 45-degree reference angle will always occur with something that ends in pi over 4. So for example, if I gave you the angle 11 pi over 6, you would think, okay, that lands in the 4th quadrant, and my reference angle is 30 degrees. The next thing you're going to do is you're going to draw a right triangle with the terminal side of the angle, the end side of the angle, and the x-axis. So your triangle will either be in the first quadrant looking like that, second quadrant looking like this, third quadrant, or fourth quadrant. You never form it with the y-axis. It is always with the x-axis. Last thing you're going to do is you're going to fill in your side lengths of the appropriate special right triangle. As we said before up here, remember the reference angle is always going to be 30, 45, or 60. So you're always going to have either a 45, 45, 90 triangle or a 30, 60, 90 triangle. You'll fill in the side lengths according to what your reference angle is. Now, you have to be careful because in the first quadrant, everything, all your legs and your hypotenuse are going to be positive. Once you move out of the first quadrant, because it's on the coordinate plane, your legs can be negative. So if you go left on the coordinate plane or down on the coordinate plane, you're going to have negative side lengths. So if your triangle is not in quadrant 1, you will have negative legs. And we will practice this a lot. So my main thing here that I want you to get in your head is to check your sines. Before you start finding the sine, cosine, and tangent, make sure you check your sines. So we're going to go through about 4 examples here. Make sure that you get nice and comfortable with how you evaluate all 6 trig functions of a special right triangle, of angles on your unit circle. So the problems today are all going to start out the same. It's going to ask us to evaluate all 6 trig ratios, sine, cosine, tangent, and their reciprocals for the following angles. The angle that we're going to start out with first is pi over 6. So using our steps above, we're going to first determine what quadrant pi over 6 lands in. You should look at your unit circle, have it out in front of you, and recognize that pi over 6 lands in the first quadrant. So we're going to draw that angle. The next thing we're going to do is we're going to determine what our reference angle is. We're trying to think how far away is pi over 6 from this x-axis. Remember, pi over 6 is equal to 30 degrees. It is 30 degrees away from our x-axis. You're then going to draw a right triangle with the terminal side of that angle, the inside, and the x-axis. We now have a 30, 60, 90 triangle. Next, you'll fill in your side lengths for the 30, 60, 90 triangle. Remember, across from the 30-degree angle, we have a side length of 1. Across from the 60-degree angle, we have a side length of square root of 3. And across from the 90, we have a side length of 2. Now, once you have drawn your triangle, filled in all your side lengths for your special right triangle, I would then highly encourage you to go back to your reference angle and label your sides, opposite, adjacent, and hypotenuse, in regards to that reference angle. So remember, on the other side, opposite side of the reference angle is the opposite side. The side that is right next to the reference angle is the adjacent side. And of course, the side that is on the other side of the 90 is the hypotenuse. Now we can evaluate all 6 trig functions using Sohcahtoa. So let's go over to the side. Sine. That's the opposite side over the hypotenuse. It's the ratio of the opposite side of the reference angle compared to the hypotenuse. So we go to our opposite, that is 1. Our hypotenuse is 2. So the sine is equal to 1/2. The cosecant would be the reciprocal of that. So just 2 over 1, which is just 2. Cosine is the adjacent over the hypotenuse. The adjacent is the square root of 3. The hypotenuse is 2. We do not need to rationalize because that radical is in the numerator. The reciprocal of cosine is secant. So we flip over 2 over the square root of 3 and rationalize, and you should get 2 square root 3 over 3. Last, tangent is the opposite over the adjacent. So we have 1 over square root of 3. Don't leave it like that. Rationalize it out to get square root of 3 over 3. Cotangent is the adjacent over the opposite, so it's just square root of 3 over 1. Anything over 1 is just a whole number, so you don't have to write it. You can just write it as the square root of 3. You have just completed your first problem where you have evaluated for a unit circle angle all 6 trig ratios. Give yourself a pat on the back and let's go to the back page. The first angle we're going to look at on the back page is 225 degrees. Please have your unit circle out and determine which quadrant 225 degrees lands in. (225 degrees) is bigger than 180 but smaller than 270. It lands in the third quadrant. Let's figure out what our reference angle is. 225 degrees is here. The closest x-axis value is 180, so subtract 225 minus 180 and you'll find that it has a 45-degree reference angle, which means once you form your triangle with the x-axis, remember never form it with the y-axis, you'll recognize we have a 45, 45, 90 triangle. Let's now fill in our side lengths of that 45, 45, 90 triangle. Remember the legs are congruent and they are both equal to 1. The hypotenuse is equal to the square root of 2. Now, you'll remember on the first page that I told you to think about how the unit circle is centered at the origin on the coordinate plane. So once you leave the first quadrant, your legs can be negative. So think about if this is the origin, if we go left on the x-axis, this is no longer a positive 1 value. It is negative 1. If we go down the y-axis, this is no longer positive 1. This leg length has a negative 1 value. So please be very precise. Once you leave the first quadrant, you need to check your legs. It will affect all 6 trig functions from here on out once you leave the first quadrant. Let's now label our side lengths in regards to our reference angle. We have the opposite, we have the adjacent, we have the hypotenuse. Now one more word about the when you have negatives, your legs can be negative, but your hypotenuse here is always positive. No matter what quadrant you're in, your hypotenuse will always, always, always be positive. So we have drawn our triangle in the appropriate quadrant. We have filled in our side lengths based upon what special right triangle we have. We have labeled our sides O, A, and H. Now we are ready to find all 6 trig functions. If you need to, write Sohcahtoa. And let's begin. The sine is the opposite over the hypotenuse. So we have negative 1 over the square root of 2. That's something you'll have to rationalize to get negative square root of 2 over 2. The cosecant is the reciprocal of that. Hypotenuse, square root of 2 over the opposite, negative 1. Square root of 2 divided by negative 1, we can just write as negative square root of 2. Let's continue with the cosine. That is the adjacent over the hypotenuse. So again, it's negative 1 over square root of 2. It's the same thing as above, negative root 2 over 2, which means that the secant would be the same thing. Last, we have tangent. Tangent is opposite over the adjacent. Negative 1 divided by negative 1 is positive 1. Cotangent is just the reciprocal of 1, which is just 1. Pause and rewatch if you are confused by anything that went on there. If you're feeling good, let's go on to 5 pi over 3. Have your reference angle out, your unit circle out to determine where 5 pi over 3 lands. Five pi over 3 is an angle that lands in the fourth quadrant. Determine your reference angle. Remember, anything that ends in pi over 3 has a reference angle of 60 degrees. Form your right triangle with the x-axis, never with the y-axis. Fill in your remaining angle and you see that you have a 30, 60, 90 triangle. Fill in your side lengths appropriately. Across from 30, you have a side length of 1. Across from 60, you should have a side length of square root of 3. And across from 90, you have a side length of 2. Now, always check your legs. Remember that this is the origin, so if we go right from the origin, anything right on the x-axis has a positive value. But if we go down, this is going to turn into a negative value. So we know that this should be negative square root of 3, not positive. And of course, just like before, your hypotenuse is always positive. Once you have those side lengths labeled, once you have those side lengths put on there, label your sides in regards to the reference angle. You have the opposite, you have the adjacent leg, you have your hypotenuse. And now you're ready to find your sine, cosine, and tangent. Pause the screen and try to fill those out on your own. For your sine, you should have done your opposite over your hypotenuse and gotten negative square root of 3 over 2. For your cosine, you should have done the adjacent over the hypotenuse and gotten a ratio of 1 over 2. For your tangent, you should do the opposite over the adjacent and get negative square root of 3. If you've done those, you can just as easily do the reciprocals, cosecant, secant, and cotangent. The cosecant, you would get negative 2 over square root of 3. Rationalized out, you get negative 2 root 3 over 3. Make sure that that is negative. For your secant, you would have had the reciprocal of 1/2, which is 2. For your cotangent, you would have 1 over negative root 3, which rationalizes out to negative root 3 over 3. Notice how when you are not in the first quadrant, you're going to have sine, cosines, or tangents that are negative. Our last angle that we're going to check out here is 7 pi over 6. Please have your unit circle handy and figure out where 7 pi over 6 lands. Hopefully you're getting more and more familiar with those angles. 7 pi over 6 is an angle that lands in the third quadrant. Determine your reference angle. Anything that ends in pi over 6 has a reference angle formed with the x-axis of 30 degrees. Form your right triangle with the x-axis, never with the y-axis. It's always a right triangle. Fill in that remaining angle, and now you're good to go with filling in your side lengths. We obviously have a 30, 60, 90 triangle. Across from the 30-degree angle, you should have 1. Across from the 60, square root of 3, and the hypotenuse has a side length of 2. Before you label your opposite, your adjacent, and your hypotenuse, check your legs. So remember, if you go left on the x-axis, this is the origin, so if we go left, we have a negative x direction, and if we go down, we have a negative y value as well. The hypotenuse is always positive. Just a little reminder there. Label your side lengths in regard to your reference angle. Opposite, your adjacent leg is always your x value, and your hypotenuse is always across from your 90-degree angle. Now we're ready to rock and roll and fill in our sine, cosine, tangent, and all their reciprocal friends. Pause the screen and give yourself a second to do those. Check to make sure you've done your sine, cosine, and tangent appropriately. Also, make sure that your signs are correct on those. For your cosecant, you should have the reciprocal of sine, which is negative 2. For your secant, you should have negative 2 over the square root of 3. If you rationalize it out, you get negative 2 square root 3 over 3. And last but not least, for your cotangent, you should have square root of 3 over 1, which is just the square root of 3. Feel free to rewind and rewatch any of those angles that we might have gone through. You're going to try 5 more different angles on your homework tonight. Make sure to always determine which quadrant your angle lands in. Determine your reference angle. It's either going to be 30, 45, or 60. Fill in your special right triangle lengths and label O, A, and H, watching your signs on those legs if you're not in the first quadrant. You've got this. It's super fun once you get the hang of it.